Hi everyone, and welcome to my talk at the workshop. Thank you for inviting me. I'm Julian Togelius, and my talk here is called Endless Frontiers, ? So I'm going to talk about my view about open world and open-ended games and why we would want to use them in machine learning, and also why we would not want to use them. Turns out these are basically the same reasons. And then I'm going to give you some examples of interesting challenges, in particular an extended example of the Minecraft, the generative design in Minecraft challenge. So let's start with, there's been a lot of work in the last 5 years or so on using reinforcement learning and other kinds of machine learning algorithms to play arcade games. Largely kicked off by the very famous DeepMind results on using deep Q learning to play Atari games back in 2015. But there's been work on this long before, since at least the early 2000s. Arcade games has for a long time seemed to be sort of the ideal AI benchmarks. Because you have well-defined tasks, you know what it means to succeed because you have score, you can win, you can lose. You have limited episode lengths. You have a single perspective, very often due to technical limitations in these early 8-bit machines. You had only a fixed camera on the screen, or maybe a camera which switched in like big discrete increments as you moved between rooms. You had a limited set of actions, so a very narrow branching factor, to use the language of board game research. And you have a largely static world. You move around, you interact with some non-player characters, but apart from that, the world doesn't change much. You see in the background here, you have Donkey Kong, and at the foreground Donkey Kong, you have the one-time world champion of Donkey Kong, proving that you can become very, very good at Donkey Kong without necessarily being so good at many other things. I highly recommend watching the movie or the documentary, The King of Kong. Now, what did we actually learn from this? What did we learn from spending countless GPU hours training giant or not so giant neural networks to play arcade games? Arguably not that much. So we've started to realize over the last few years that these neural nets trained arcade games don't really learn something very transferable. In general, they don't generalize to other games or to other non-game tasks, or even to other levels of the same games, or the same game when rotated, added noise to, flipped upside down, or anything else. It could be argued that we aren't really learning to play these games. We're merely learning something more akin to giant lookup tables, which say, like, in this situation, take this action. In this other situation, take this other action. You're seeing some references here to some recent research about this, and the screenshot is from one of our papers where we try to investigate how we could learn general game playing skills in the GVGI suite of games. So GVGI is like a generalized Atari. GVGI stands for the General Video Game AI framework and benchmark. It is like a generalized Atari game playing challenge. You have a lot of games which are simple two-dimensional games, but you can define new games very simply by coding them up in a special domain purpose language. And you can create new levels, and you can very easily create new levels algorithmically. What we found was that a policy that was trained to win a particular game could basically only play that game and that particular level. You change the level a bit, it doesn't work. We managed to show that you could actually generalize a little bit by feeding it an endless stream of new levels, but it never got to the point where it could play any arbitrary level in even a simple game. So something is wrong here. We're not learning what we want to learn. We're not learning policies in general. So therefore, more and more people have recently started looking at, could we maybe try to apply our machine learning techniques to more complex games, games that don't have these limitations. Games which are open worlds or open-ended in some way. Games like, going from the top row here, Skyrim, which is this enormous open world with a very, very expansive set of quests that you try to solve. Or Grand Theft Auto here to the right, Grand Theft Auto 5, for example, very detailed simulation of some kind of parody of modern America. Or Dwarf Fortress in the end, which with a thoroughly terrifying user interface and an extremely detailed simulation of what's going on. You may not see it from the screenshot, but you're controlling this giant fortress of dwarfs, and as they are sort of enduring wars and disasters and so on. And the simulation goes down to the level where you can put individual socks on the different feet of each individual dwarf. But these are like open world games with more or less well-defined tasks. Now, if you look at the bottom row, it gets trickier because you see here Animal Crossing, New Horizons to the left, is very popular right now. It's more like a dollhouse or a toy. You don't really necessarily have a set of tasks you need to fulfill. Well, you have a lot of tasks you can fulfill if you want to. The game gives you missions, but that's not the point, really. The point is doing what you want with it. Or SimCity, this is one of SimCity versions where you are creating a whole city. And sure, you can try to sort of, fulfill various quests, but that's not the point again. You're building a city and trying to express something with it, or just having fun. Minecraft, famously a single sort of action, not famously a single player game, which is anything but, because there are also quests, but really it's all about building things, preferably in combination with others. Or Factorio here to the bottom, where you build factories to produce things. And it's all about your inventiveness in coming up with new ways of making things. So many people have thought that here's where we should be going, or many people, quite a few people have thought this is where it should go. No, we did these standard classic board games, and then we moved on to simple arcade games, and we moved into very complex sort of adversarial games, and now we'll be going all into open-ended, open world games. But I'm not sure. I'm not sure we should do this, or I think we should do this, but I'm not sure we can treat them like we did with the other games. So open-ended games are actually terrible benchmarks for basically the same reasons that the arcade games are great benchmarks. And they're terrible benchmarks for the reasons that they don't generalize well. So looking at this, we have episode length and action space. This is a screenshot from Civilization. Is it 5 or 6? I think 5. Could be 6, forgot now. You have an absolutely ridiculous branching factor. So if you think about it, whereas an Atari game has, I think, 6 possible actions in each frame. Chess, you have a branching factor of 35, Go about 300, 350. In Civilization, if you have 10 units, and each one of these units can move to one of 10 different places each turn, which is a very, very, very low, which is a very small game of Civilization here. Your Civilization is very tiny at that point. Then you have a branching factor of 10 to the power of 10, not even taking into account the cities. Now, the episode length is also ridiculous because we're talking about a few hundred turns at least, and in each turn there's so much going on. Even calculating transition from one turn to the other is quite expensive. So this might not be a good benchmark for that reason. There's also a factor of perspective. I talked about before that standard classic arcade games have a single perspective, and even more complex games such as StarCraft, you're typically focused on a map. You may move around on a map, but there is a clear sense of spatiality to it. Now, Civilization 5 also has a map, but the other screens here are just as much this game it is. It's basically, in interface-wise, it can be compared to a piece of productivity software like Microsoft Office or something. There's a lot of different perspectives going on all the time. You can, of course, zoom in and out on a map as well. This makes it very, very hard to treat it the same way as you do with these arcade games, where you feed it like a pixel view of what's going on and expect it to just like figure it out. Perhaps most important of all, you have the tasks. So I'm contrasting two famous open world games with each other. We have to the top here, we have the quest list in Skyrim. And as you can see, whoever has been playing this particular game of Skyrim has been playing for a while and has a whole bunch of different quests open. And there's quests, and there are sub-quests, and there are side quests, and quests. You can, of course, do those. There's a way of playing Skyrim where you do all the quests one after another. Except you have the fact that some quests will keep respawning, and you will sort of there will be more and more side quests appearing as you play, so you may want to focus on the main quests. It's not necessarily the most enjoyable way of playing Skyrim, but you can do that. Now, however, to the bottom here, we have a chicken factory in Minecraft, which grows chickens, slaughters the chickens, washes them, and produces food for you. Someone did this and posted it online. I think many people have done similar things. There is absolutely no quest for you doing this. In fact, the quests that are included in the game are very different, and this is not, this is not something that the game ever tells you to do, or ever tells you something that would make you do this. But this is what the game is all about. The game is all about this inventiveness and coming up with weird things that shouldn't exist. So what I'm saying is that maybe we shouldn't try to shoehorn these games into a traditional reinforcement learning framework. We can certainly do it. We can sort of squeeze Minecraft into a situation where you have tasks and you have rewards and so on. In fact, there is one or two competitions that is trying to do exactly this. I'm not saying these are bad competitions, far from. They are using Minecraft to create a new reinforcement learning setting, but it's sort of missing the point, isn't it? Because that's not what the game is about. So many open world and open-ended games feature various ways of changing the world. In fact, in many cases, that's what they are about. To the left here, we see one of the more sort of the less consequential ways of doing this. This is the cooking in Zelda Breath of the Wild. If you play the game, there's a delightful sort of pervasive mini game in cooking based on all the kinds of things you find. It's very enjoyable just to sort of, throw things together and see what you get. A little bit like cooking at home with lower stakes and more variety. And to the right here is SimCity, where basically changing the world is everything there is. So how can you possibly do AI research out of this? Well, you can. I would venture so far as to say that the only creative play, or the only truly open-ended play, is creative play. The one where you create things. You do not just follow instruction. And if we're going to work with open world and open-ended games, the really interesting challenges is about making agents that create their own environments and define their own challenges. So here we have Sam Earle, then an independent researcher, just about to start his PhD in my lab, using a form of deep reinforcement learning to learn to play SimCity. What is he doing here? Well, the agent is looking at the screen and placing residential zones, industrial zones, and commercial zones, and changing other variables of the game. You can change the tax rate and all kinds of things. Also demolishing them, building roads, and cities are growing and cities are changing and cities are sort of dying in front of us. Now you may wonder, how good is this? Did this break state of the art on SimCity? Well, there is a way you can ask that question. You can ask the question, did it sort of, one way of thinking of state-of-the-art in a city is like, how much population can you fit into a city on a particular map? Now, that's a pretty bleak view of city building. There are many more interesting questions you can ask about this, such as, for a given optimization objective, what kind of cities is it creating? What's the ideology of SimCity as embodied in its game mechanics? There's actually, you may or may not be surprised by this, been a substantial amount of discussion about what sort of politics are embedded in SimCity. Is it a libertarian game that sort of forces you to make functionally separated cities and throw away public transport? Is it a game that instead argues implicitly for public transport? Is it something else? Does it argue for higher low tax rates? Well, one way of sort of settling this questions is building agents for the games and watching them play under various reward regimes and seeing what kind of cities it creates. Now, here is exactly the same method being applied not to building or not to playing a game, but to build levels for a number of different games. So here we have a reinforcement learning algorithm in exactly the same setting as the SimCity you saw before, building various kinds of levels for a simplified Zelda game, for Soccer Band and so on, with relatively good success. So playing and building are not necessarily in opposition to each other. It's facets of the same thing. So I think I'd like to finish by showing you an example of a competition we're running now. It's running for the third year, and we recently had final submissions, and fortunately I don't have the third year results yet, but I can talk about the second year results. It's the Generative Design in Minecraft Settlement Generation Competition. The name is a bit of a mouthful, but I hope you can appreciate the competition and how different it is from other competition, including those built on open-ended games. So the idea here, here you can see this quite fascinating video of, these are actually a team of humans building a settlement in Minecraft. And of course, this is sped up. I mean, this work was undertaken over days. The idea here is that you create agents that create Minecraft settlements, cities or villages or whatever you want to call them. And they must not only be nice looking and seemingly sort of coherent, but it must also adapt well to the place they're built on. So this city here you're seeing being built is nicely adapted to the sort of hill by the lake or hill by the ocean environment it was given. They also need to produce evocative narrative. You can sort of walk around in them and figure out, what is this? Why was it built? Were these fortifications here to defend against pirates and so on? So we built a technical framework based on a tool called MCEdit, Minecraft Edit. It's Python-based. We now also have a separate Java framework to do this. And the way it works is you build your agent, which is called the filter, because we're adapting the MCEdit terminology. And then you submit the agent to us. We give it maps that you have never seen before, and then see what your agent works with here, what it does with it. So we have a panel of judges because we could not think of any ways we could write code to do this evaluation for us. We give all of the submitted agents 3 unseen competition maps, which maybe they're freshly generated, maybe we find them in some obscure place. It's supposed to be unlikely that you, as a competition entrant, have ever seen them before. And then we evaluate 3 maps for each entry. Judges evaluate them. So the 4 main criteria are adaptivity, how well does it fit into the environment it was given, functionality, how functional is it? Are houses close enough as they should? Are roads leading up to them? Are roads going to nowhere, etc.? Evocative narrative. Does it feel like there is a story behind it? Does it make sense? And then aesthetics, which is basically, does it look nice at all? So from 2019, we had 6 entrants. Most of them used a combination of scripted rules and a number of classic AI techniques. There were basically all of them used various versions of pathfinding in different places. And we had a group of judges, including game design experts, people working in graphics, people actually working in architecture, some Minecraft aficionados, including Minecraft streamers and so on. So we had a diverse group of judges to judge this. To show you some examples, third place here by Lisa and Brian Carter. Given this, I'll show you exactly the same view of the same natural feature and the cities that were built around it. We have second place, the username Julius14 that built this. His generator created this sort of more medieval looking village with some kind of tower on top of the mountain here. And in first place, Philip Skorsky, who may have been less adaptive in this case, but built just very nice looking, thoughtful villages around. Well, I mean Philip Skorsky didn't do it, but the generator Philip Skorsky had built these things. Right, so my time is up, and if I want to sum up what I said about here and what I said here, maybe my most important message is that if we're going to deal with open world games and open-ended games, we should change the kind of things we're trying to make them do, and in particular, try to look at how can we build competitions where you have to submit agents that actually build something. And how could we evaluate them? Right, thank you. Time for questions.